In this video, we're going to be talking about the conic section, the ellipse. So if you take 2 points in space and a third point, and we're to connect all three of them, so we take this point here, connect it to this point here, connect it here. If we were to look at the sum of the distances between these 2 points, so the sum of this distance from here to here and here to here, we would find that all of the points in space whose sum is equivalent to these two that are connected by these 2 points would form our ellipse. So if I just picked another arbitrary point like this point here, and I connected them to our 2 points here, like this and like this sum, the sum of this length to this length, would be the same as the sum of the 2 lengths that we have here in purple. That would also be true if I picked a point here. This length from here to here added to this, so this length added to this length, that length is the same as the sum of the 2 lengths in green or the sum of the 2 lengths in purple. So if we took a look at all of the collections of points that have this same sum of these 2 lengths, that would form our ellipse. So there's a few key features that we have to look at before we can start talking about an ellipse. So you see that we have something called like the major axis, the minor axis, center, focus. So we want to identify all of these key features before we can actually talk about what we use them for. So the major axis is just this axis here. It's the longer of the 2 axes that run through the center. And then the minor axis is the shorter of the 2 axes. So there are 2 axes. The long one is the major axis. The short one is the minor axis. Both of them go through the center. So the center is just at the center of our ellipse. But they also intersect a few other key points. So the points on the outside of the ellipse where our axes intersect the ellipse, those points are called vertices. Now, the vertex that the book refers to is primarily the vertex on the major axis, so these ones here. However, these minor axis, these are also vertices. They're sometimes called co-vertices. So they're called co-vertices because they're not always deemed as important. I don't know why, but they are. So we call them co-vertices. But when the book asks you to find the vertices, they really only care about those on the major axis. There's also focal points. So they're the foci. So that's the plural for focus. And they're these points in red here. So those are our foci. The foci are both the same distance from the center. So let's talk about the different lengths, the different distances, and what we refer to them as. So if we're looking at the center, the distance from the center to the major axis vertex, or just the regular vertices, this center here, we call that value A. We use A to represent that value. The distance from the center to the minor axis vertex, this distance here, we call that distance B. And then the distance from the center to our focus, this distance here, we call this distance C. So this is B from the center to the minor axis, and the center to the focus is C. Now, these 3 measures have a very unique relationship. We can see that we could actually form a right triangle here, and it just so happens that this right triangle has a hypotenuse length of A. So B squared plus C squared is equal to A squared. So that's the one of the relationships between A, B, and C, is that B squared plus C squared is equal to A squared. Now, it's a little bit different order than the Pythagorean theorem that we're used to. Normally, we think A squared plus B squared equals C squared, but the longest of these lengths is A, so that's going to make it the hypotenuse here. Now, also, we know that A is always greater than B, because again, it's the longest length, and they all are always going to be positive. So you'll never have a negative measure for your major axis or your minor axis distance. So we can just manipulate this equation as much as we need. So if we know the value of our the length from the center to the minor axis and the length from the center to the major axis vertex, we can find c by subtracting b squared on both sides. Or just depending on what we know, we can subtract the ones that we need in order to help us find the different measures.